In today's world, we're not just dealing with data. We are facing a full-on data fire hose. So how do modern companies manage this constant, overwhelming flow without getting totally washed away? Let's dive in and see how they tame this beast.
Seriously, just stop and think about this for a second. At any given moment, a company like Uber is processing ride requests, location updates, payment calculations, driver notifications, all happening at the exact same time, all over the planet. How on earth does the system not just completely collapse under that kind of pressure?
Well, the old way of doing things, it's just total chaos. Imagine every single service trying to talk directly to every other service. The pricing service has to ping the map service, which then has to ping the user service, which then pings the payment service. It becomes this incredibly fragile, tangled web. And if just one of those connections breaks, the entire system can grind to a halt.
And this tangled mess, it's not just some sloppy design. It's the fundamental problem we're going to call the real-time data challenge. And it's something that pretty much every large-scale modern application has to solve if it wants to survive.
See, the heart of the problem is that data isn't just sitting quietly in a database anymore, waiting for you to ask a question. No, it's constantly streaming in from user apps, from website clicks, from all kinds of sensors. And you have dozens of different applications that all need to react to it, like right now. Your traditional methods just can't keep up.
So what's the fix for this mess? Well, you need something that acts like a central nervous system for all your data, a single, super reliable backbone that everything can just plug into. And for many of the world's biggest companies, that solution is Apache Kafka.
So what is this thing exactly? Officially, Kafka is a distributed event streaming platform. Right, that's a bit of a mouthful, but the two words you really want to lock onto are event streaming. It's built from the ground up to handle data that is always on the move.
So why is everybody so hyped about it? Well, its power comes down to a few really incredible things. It can handle a crazy number of messages. We're talking millions per second. It's durable, so your data is safe. It's fault tolerant, so if a server goes down, it's not a catastrophe. And the big one, the real game changer, is decoupling. That's the magic trick that untangles that whole spidery mess we were just talking about.
Okay, so we know why it's so powerful, but how does it actually work? Let's pull back the curtain and take a look at the surprisingly simple, elegant pieces that make Kafka tick.
So, it all starts with what's called a producer. This could be anything, really. Your phone sending a location update, an e-commerce site logging a new purchase. Its job is to produce an event and send it out. See? Simple.
So where does that data go? The producer shoots it over to something called a topic. Now, the easiest way to think about a topic is just a dedicated channel, like a logbook just for orders, or another one just for user signups, and another one for payments. It keeps everything nice and organized. And then on the other side, you've got the consumer. This is any app that needs to react to that data. It tunes into a topic, like the orders topic, and gets a live feed of every single order the second it happens, so it can do its job. And the glue holding all this together, that's the broker. A broker is just a Kafka server, a computer. And companies don't just use one. They run a whole team of them, called a cluster. So if one goes down, no big deal. The others just pick up the slack. So you see the flow, right? A producer sends a message to a topic, which a consumer then reads. That's it. It's so clean and logical. No more of those direct, tangled connections. It's just beautifully simple.
But hold on a second. That flow, it seems a little too simple to handle millions of messages every second, right? How can one little channel handle all that traffic? Well, this is where we get to the secret sauce, the real magic behind Kafka's insane speed. The secret is this brilliant little idea called a partition. See, instead of a topic being one single long line, Kafka chops it up into multiple lines, or logs, that can all run at the same time, in parallel. This right here is the absolute key to how it scales. So check out how this creates this parallel power. You take one topic, let's say orders, and you split it into, 3 partitions. Now you can have 3 producers writing data at the same time. And even better, you can have a team of 3 consumers reading all that data in parallel. Boom, you've just tripled your speed. And if you need to go faster, you just add more partitions. It's that elegant.
All right, that's enough of the theory. Let's see how this stuff actually plays out in the real world. Where are companies you use every day putting all these producers, topics, and partitions to work?
Let's go right back to that ride-hailing app.
When you request a ride, your phone acts as the producer. It fires off an event to the ride request's topic. And instantly you have multiple consumers, the matching system, the pricing engine, the notification service, that all read that same event and do their jobs at the same time without any of them having to know the others even exist. That's decoupling in action.
It's the exact same idea in e-commerce. You place an order. That's the producer sending an event to the order's topic. Right away, the payment service, the warehouse system, and the shipping department all act as consumers that are instantly told to start their work. It's a perfectly coordinated dance.
And how about a really high-stakes example? Banking. Every single time you swipe your card, that's a producer sending an event to the transactions topic. A consumer, which is the fraud detection system, can then analyze that stream in real time to spot anything suspicious, literally fractions of a second after you swipe. That's real-time power.
Okay, so Kafka is obviously a powerhouse. But, and this is a big but, it is not the right tool for every single job. And that brings us to the final and most crucial question: when should you actually use it?
The decision really comes down to this. If you're dealing with continuous streams of data, massive volume, and you absolutely need real-time processing across a bunch of different systems, Kafka is probably what you're looking for. But if you just need a simple task queue or you've got a small, low-volume app, it is definitely overkill, and it's probably going to cause you more headaches than it solves.
So, at the end of the day, if there's one thing to remember, it's this. It all comes back to that first definition. Kafka isn't a database. It's a platform built for data in motion, for streaming events. If you remember that, you'll know exactly when and why to reach for it.
So I'll leave you with this final thought. The way we think about data has really shifted. We've moved from a world of quiet data reservoirs to one of constantly flowing data rivers. And the real question you have to ask yourself is, are the systems you're building designed for the quiet reservoir, or are they ready for the stream?